All right. So I said I found two examples, and that should clear everything up. Stationary waves, wasn't it? Now, did you all understand the message I sent to you?
Kind of.
Do you understand the mistake we were making, or I was making?
Yeah, that it was two different wavelengths.
It was two different wavelengths, and my equations I had lambda and lambda, whereas I should have had lambda 1 and lambda 2. Yeah.
But didn't we say that the wavelength didn't change, it just changed the length?
Oh, that was because that was for one type of one wavelength.
Yeah. So look, anyways, we'll clear this all up now with two examples, okay? Yeah, I have two examples here. So here's the first one. A stationary sound wave of frequency 256 Hz is formed in a 31 centimeter pipe which is closed at one end and open at the other end. So let's draw that first, okay? Okay, so you have your pipe. You have your pipe. And you have your wave inside of it. And it's the first harmonic. So here is a node, and then at the other end,
It's just antinode.
antinode. Now, do you notice how I drew it a little bit outside?
Yeah.
Okay. So this here is a length of 31 centimeters, and this here is our delta L. Yeah? And also the frequency here is 256 Hertz, and the speed of the sound is 340 meters per second. So we can say 1/4 of the wave length is equal to 0.31 plus delta L. Okay? We can also say V equals lambda F. Yes?
Mm-hmm.
So if I sub that in there, I get V equals 0.31 plus delta L F. Yes? Because I could just multiply the 4 up there. Okay. So now I have 340 equals 4 times 0.31 plus delta L times 256.
Mm-hmm.
So that's 340 over 1024 minus 0.31 equals delta L. So the end correction here is whatever that is. Yeah, and that, I don't know if you remember the question, but that is the answer. 0.022, so meters then. Okay, so that one's okay. Now it's the next one that's a little trickier, but we'll do it once you write that down carefully. Yeah? Do you want to write this down?
I don't have mine.
Well, do you have any paper?
Oh, okay.
You should write it down and transfer it, okay?
You know, I'll watch the videos. Just
Will you? No, write it down. It'll make me feel better because I'm not sure if you will watch the video. I think you'll go home and enjoy the weekend and forget about this.
no, because I have to do a bunch of stuff. So
Did that just break?
Oh, it was always broken.
Was it? Okay.
let's see.
Come on, Diego.
Open it up.
Oh,
So you can continue.
okay.
Do you have paper? Should I give you some?
No, he has paper. He's just being awkward.
Somewhere in here.
Is that okay?
Yeah.
Okay. You got that? Yep. Next one. Now, in an experiment to measure the speed of sound, so this time we don't know the speed of sound, a note of frequency 512 Hz was sounded above the open end of the air column, closed at the other end. The first position of resonance occurred when the length of the air column was 0.162, and the second position of resonance occurred when the length of the column was 0.494. So, let's see what we have here. You have your pipe. And they fill it up with water. Okay. And you get your wave here, like this. Okay. And what's the length here? We're told it's 0.162. 0.162. And then once again, it actually forms a little bit outside of it. So here we'll call this delta L. And the frequency is going to be 512. 512 Hertz then. Okay? Then what they do, they let some water out. And they do that until they get the second harmonic. Okay? Isn't that right? The second position of resonance occurs when the length of the air column was 0.494. So the frequency here is, they're still using the same tuning fork. So that's 5112 Hertz. Now, it's still the same wave, just longer. So how much, okay, so I should actually write it here. How much of the wave could we capture here? We got a quarter of the wave. If I keep dropping this until I get the next resonance, yeah, I should be able to get 3/4 of it. And the information here is a little bit different. This is now 0.494. And then we still have our delta L here. Now, do you see in this one, guys, in this one here, the wavelength, is it the same or different for this one?
It's the same.
If this one's the same, yeah. That's what I was getting confused about. And the reason it's the same is because we've actually changed the length of the pipe.
But the wave stays
But it's the same wave. It's just, yeah. So, here, we can say lambda over 4 equals 0.162 plus delta L. And here, 3/4 lambda equals 0.494 plus delta L. So, what did I say the frequency was?
Those two deltas are the same or not?
Yeah, they're the same. Yeah. Okay. So here, V, which we don't know, equals F lambda. Yeah. And here, V, which we don't know. Oh, sorry, we don't know. V, which we don't know, equals F lambda. Yeah? Is that right? Is it the same F? Yeah? They don't say that they change it, so it must be the same F. Okay. So, what do we do next? We want to solve for, what do we want? Determine the n correction. So we want the delta L. So I think I can make these equal. If I make these equal, I get 4 times 0.162 plus delta L equals 4 over 3, 0.494 plus delta L. If I make these equal, I can cancel the 512. Yeah? Actually, what else can I cancel? The 4, can't I? Yeah. So now I have 3 times 0.162 plus 3 delta L equals 0.494 plus delta L. So I get 2 delta L equals 0.494 minus 3 times 0.162. Divide by 2 and I get my delta L. So what's the delta L here? Hopefully a small enough number. Good, so that's 4 millimeters. Now, just so you know, I said this before, but it's also just as a little side note that the delta L is roughly equal to the radius of the pipe, roughly. So that must have meant that the pipe, I would say, was about 8 millimeters, roughly.
That happens with pipes
Yeah,
that are circular.
yeah.
But if you have a square pipe
Oh,
or a triangle,
I'm sure it'll be different. Yeah. Okay, is this one okay? I hope that clears it up a bit for you. Did you get all of that written down? Got that? Yeah. Yeah, that's okay? Yeah. Now, let's see. Okay, okay. So, can you, what is your timetable on Moodle, or is it not uploaded? Is it just for this week?
Yeah.
So, what days did we have physics this week?
Tuesday, I think. I think it was Tuesday, Thursday, and today.
Yes. No. Yeah. Tuesday, Thursday, today.
And so next week we know which day is impossible. Thursday is impossible?
Yes.
Thursday, yeah. So
Wednesday could be in the morning.
Do we normally have a Wednesday?
No.
I thought the fair was on Wednesday.
It was
Wednesday morning.
Wednesday afternoon, and
Afternoon,
Thursday
so morning,
the
we
all day.
might have something.
No, I know the fair is 1.5 days.
So yes.
So Wednesday is...
Half
Tuesday
day.
and Thursday and Wednesday. It's when the fair is.
Oh, not Thursday, Friday. Wednesday, Thursday.
Yes.
So Wednesday and Thursday, unlikely to have classes. So unless they move it, it's going to be Monday, Tuesday, Friday. But I don't particularly want Monday. And Friday, today is 2 hours.
Yeah.
So it's going to be Tuesday or Friday.
or
In the
maybe
morning.
Thursday afternoon.
Or maybe
Oh,
No,
Thursday.
no, no.
Morning,
Thursday's
morning.
all day. It's
Oh.
either Wednesday morning.
Wednesday morning.
Or
But that's
Friday morning.
unlikely because I have tutorial with the science students.
Okay.
But they're gonna reshuffle everything
Oh yeah, that's true.
because
Tuesday,
students are also
Friday.
going to that.
Tuesday.
Everybody's going.
Okay. Okay, but you are unsure of Friday because you might be away?
No, I'm just leaving on the afternoon.
What time?
Like 3 or something.
Oh, okay. Oh, so actually it could be Friday then still.
Depends on what time it is.
I would like to do it Friday. So if it turns out on your timetable for next week, if the class ends before 3 p.m., then we'll do it on Friday.
No, but you can't. What time do you have to leave?
Leave.
Because you
Well,
have
Well, where are you going Friday?
London.
Oh, what do you want to go there for? All right.
Investments.
Yeah. What time do you have to leave here on Friday?
I'm just saying.
There's only 6 of you, but it's so difficult to arrange things when, you know, some of you get viruses and the other of you have to go to London and one of you wake up at 10 o'clock.
My friend is leaving at 15:30, so if I leave here at 14.
2 o'clock.
Yeah.
Right, okay. If the physics class finishes before 2 o'clock, so Diego can get his flight, we'll do the lab on Friday. Okay? If this cannot happen, if the physics class is after 2 o'clock, maybe it finishes at 3 o'clock, then we'll just move it to the double class before that. Now that's unlikely to be on Wednesday and Thursday because of the fair, so that could be on Tuesday. In other words, I want to do it in the last double class of the week. The last double class of the week. Unless it means Diego misses the class on Friday because it goes after 2 o'clock. Then that's not going to work then. Okay. That should give me enough time to buy my batteries and double check the electrical equipment and find my retort stand and meter stick. So that should be okay then. Yeah. Now have you sent me the plan? You sent me the plan?
No, I have to do it. I have my computer now. So.
You sent me the plan? And you sent me the plan. And do Zach and Gina, we'll have to check with them. Gina sent it, yeah. Did Zach send it? I'm not sure. Okay. Have you done are you finished your chemistry lab report?
Well,
No.
technically no. But
I mean,
practically, yeah.
Just first draft.
just the first draft. Okay, so you can now start working on the physics.
Basically.
Yeah, I guess so.
Is it the same?
Because you'll only be tweaking the
Chemistry.
chemistry.
Is it the same
Yeah, pretty
way,
much.
or
Yeah,
do you
yeah,
have
yeah,
to
yeah.
change?
Yeah, I might do a little bit. I might focus a tiny bit more on the analysis, but not really. It'll be similar to what you did in semester 1.
So I have to like do a whole introduction
Yeah,
as well.
yeah, yeah. Now look, guys, if you wanted to get started, I mean, we're going to give time in class, but if you wanted to get started on it, you know, you could start with like the writing the theory, you know, because what you need to talk about is you need to this weekend find your notes for the proof of this formula. Do you remember we did the proof of this in class?
Oh yeah.
Oh, yeah.
Okay.
Yeah. You might want to start typing that proof up even. Yeah. And then the other one you'll need is the proof of S equals ut plus a half at squared. Because you used both of these formulas, didn't you?
Yeah.
In the first and the second one. Where are both of those proofs? They are in your mechanics notes in semester 1.
Yep.
Mhm.
So you're going to need to have to find those, okay? You should still have them, I hope.
Yeah.
What else might you need to get for the weekend? Oh yeah, so look, the other thing is, just like with the assignments, you need to have some references. Okay, and it's the same for your physics lab report. So some good references you can find if you have time to get a start early. It's really nice if you can reference some physics books, in particular for the definitions of things. You know, it's also nice if you can reference other stuff.
Do you think that they have physics books here?
There's physics books in the library, and there's physics books on Moodle. You know, I think I can give you the guidelines, but I think your introduction needs to have a minimum of, I think, 3 references. So don't worry, we'll talk about this in class, but if any of you want to get an early start on things so you're less rushed, you can, you know.
What is it?
Because you don't need the results to start typing up the introduction. No, the deadline will be in a few weeks, like 4 or 5 weeks. Okay. Are you the? Yeah. Somebody sent me a picture, and the clock looked like a little person. Who was that?
Oh.
Was that you? The clock, and it had little hands like this.
It's
Was that you? Yeah, like Mr. Clock. Yeah. Okay. Nice. Okay. So look, we'll wrap it up there, and if we have class on Monday, we'll do the next chapter. We'll get a start on is fields then. That's the hardest one. Okay, Gina, like and subscribe. What? Grinders?
the grind.
See you next time, Grinders.